Vector addition diagram for an object equilibrium, but it's a pretty tough one because it requires you to apply certain strategies and techniques you have learned in mathematics. So we noted that this object is in equilibrium. There are actually three forces acting on this object. There's this horizontal force in the horizontal chain, that's 140 newtons. There's also diagonally upwards force in the metal cable that is given to be 280 newton, and finally the weight of the traffic light is pulling it down. So when the traffic light remains stationary, the sum of all these three forces will get you a resultant force of 0. That is why the object is at equilibrium and is not moving. We have to find what is the value of the weight. So the question is difficult because the angle theta is not given to us, but there is a way to use construction techniques to figure out what is the angle theta that the force in the metal cable makes to the vertical, and also what is the value of the downwards weight of the object. So as per all scale diagram, double check the first two things. Number one is scale, and number two, that your diagram is as big as possible. So I will start with a starting point, and I will start with the known vector that I know everything about. I know that this vector is 140 newton, and I know the direction is exactly towards the right. So I draw a horizontal line, measure it to scale. According to my scale, this line should be 14 cm. So draw it accurately. Now, the next vector that I will add is the 280 newton vector. The problem is I don't really know what is the angle of this 280 newton. So, but I do know the length. The length is 280 newtons, and according to my scale is 28 cm. So what I can do is I can use a compass to stretch the compass out to 28 cm, or to the length according to your own scale, and I just draw an arc that shows points that are 28 cm away. So that is exactly what I did here in my diagram. I use a compass and I draw an arc centering at the arrowhead just now. Draw an arc, and my arrow could have been any of these. In fact, I could have drawn more green vectors over here. So any of these vectors, they are 280 newton, and I do not know which one exactly is the accurate angle. But the next step will allow me to find the answer, because I do know that my weight is a vertical line. It must be a vertical downwards vector. So with this, if you look at the red dotted line that I constructed, that is the only way to draw a downwards vertical line that closes off this vector diagram. So this intersection point tells us, or tells me, that that is the only downwards vector to draw, and I've now eliminated all the green vectors short of one, and therefore with this I have the complete vector diagram. I can then measure the length of the red vector to find out the weight, which is 240 newton. I can use a protractor to measure the angle theta, which is 30 degrees.